In this video, we will be performing percent yield calculations. The percent yield is actually the extent to which a reaction's theoretical yield is achieved. The theoretical yield is the amount of product that's produced based on the stoichiometric calculations, but the actual yield of a reaction is the amount of product obtained in practice. Now, the reasons for less than 100% yield could be the reaction was inefficient, it may have produced other byproducts, it was an incomplete reaction, it may not have been given a chance to go to completion, or there was some unrecovered product, or product is lost, spilled, or otherwise unrecoverable. Now, percent yield is calculated by the actual yield of the reaction divided by the theoretical yield times 100. The units for actual yield and theoretical yield can be anything as long as they are the same. You can compare moles of actual yield to moles of theoretical yield, or grams of actual yield to grams of theoretical yield. In this example, we're asked to calculate the theoretical yield of aluminum oxide upon complete reaction of 5.50 grams of aluminum, assuming an excess of oxygen. Once we have the theoretical yield, we're asked to calculate the percent yield if only 2.33 grams of aluminum oxide were obtained. Now, we haven't been given the theoretical yield. We're going to have to calculate that based on the 5.50 grams of aluminum we've been given. So, as with any stoichiometric calculation, we start with the data we've been given. We take the 5.5 grams of aluminum, we convert it to moles of aluminum, and then moles of aluminum oxide, and then convert the moles of aluminum oxide to mass of aluminum oxide. Dimensional analysis checks out when we have 10.4 grams of aluminum oxide. That's the theoretical yield, assuming everything went to completion. However, we've been told that we only isolated 2.33 grams of aluminum oxide. So to calculate percent yield, we take our actual yield of 2.33 grams and divide that by the theoretical yield of 10.393 grams. Now, I notice that we are using a different value for the theoretical yield here than we calculated above. We rounded our original theoretical yield to 3 significant figures, based on the 3 sig figs that we were given in our 5.50 grams of aluminum weighed out. However, that was an intermediate calculation. If we're going to take that value on to perform other calculations, we need to use an unrounded value. So in this case, 2.33 divided by 10.393 times 100 gives us a 22.4% yield for this reaction. Now, that's not the only type of calculation you may be performing with percent yield. For example, the synthesis of heroin from morphine usually proceeds at a 75% yield. Based on this yield, how much morphine is required to produce 50 grams of heroin? Assume an excess of acetic anhydride. So what we've been told here is that if we want to make 50 grams of heroin, we have to take into account that this reaction only proceeds at 75%. It's not going to go all the way, or perhaps there's some byproduct, or maybe we've lost product because someone stole some of it. So we take our calculation for percent yield. We know our actual yield is only going to be 50 grams. That's our target. We don't know what our theoretical yield is, but we do know that our percent yield expected is 75%. So we need to rearrange this portion of the equation to solve for theoretical yield. And this means that we need to aim for 66.667 grams of heroin if we want to account for the 75% yield for this reaction. So what exactly does this mean? What do we do with this number? Well, this is our target yield. We want to aim for this so we actually get our 50 grams. So we take our 66.667 grams of heroin, we convert that to moles of heroin, and then moles of morphine, our starting material or our reactant, and then from there we convert that to mass of morphine. So according to this calculation, we need to start with 51.5 grams of morphine in order to produce 50 grams of heroin, which will only have a 75% yield. Now we can check this. If we start with our 51.5 grams of reactant, convert that to moles of morphine, and then use the 1-to-1 ratio of heroin to morphine in the stoichiometry, and then convert moles of heroin to mass of heroin, we were expecting a theoretical yield of 66.67 grams of heroin. However, at only a 75% yield, multiply that times 75 divided by 100, that would only give us 50 grams of heroin, which is our target yield.